Okay, you're gonna really have to scrunch up your brain today, all right? You're to really just, it's gonna take some extra brain power to really think about it, and then once you get it in there, lodged in there, then it's gonna be smooth sailing from the rest of the way, but it's gonna take a little bit of a mind shift, okay? All right, so let me give you an example. All right, suppose you have a graph that looks like this. We're familiar with that shape. Okay, we know it to be a sinusoidal graph having a model of increasing and then decreasing. Usually those are based on time, so we'll have t along our time axis right here. There's some important places. The values are less relevant, but let's agree to label them as follows. Let's agree to label this as A. That's the point where it's hitting the x-axis. And let's agree to label B as this point of maximum right here. And we'll call C that one. And then let's agree to label D the minimum value down here at the bottom. And then we'll call E back where it comes back to the x-axis. So the numbers are not important, it's more like where the letters are. Okay, now if you're just looking at that graph and I said, you know, when is it going up and when is it going down? Most of you could pretty easily tell me it's going up from where to where? Where is this graph going up from? Oh, and we'll call that 0, okay? So where's this graph going up? 0 to B, and where else? D to E, okay? Now, if I tell you, so most of you, okay, and it's going down from B to D, okay, we're all fine. I have not labeled the y-axis yet. So now I'm going to label the y-axis, and I'm going to tell you this is a velocity graph. That totally changes how you answer those questions of where something is going up versus where something is going down. Because this is now a graph of the velocity. It's not a graph of the position. It's not a path that the object is taking. The object is not following this path. This is the graph of the velocity. And so the questions are answered differently, which is why you really got to scrunch up your brain to think about it, as long as you understand the definitions. So let's go with what our first question is. Going up. The definition of something going up is when it has positive velocity. All right, when it has positive velocity. That's the definition of going up. V of t is greater than 0. So on this graph, where is the graph greater than 0? From where to where is it greater than 0? A to C. Now, sometimes that throws people off because they're like, yeah, but from B to C it's going down. No, that has negative slope. That doesn't mean it's going down. Okay, when it has, the definition of going up is when any part of the graph is greater than 0, which means above the x-axis. And so we answer this as from B time to C. Oh, thank you. I said that, and then I wrote the wrong thing. Or I mean, I said it earlier. A to C. All right, so by converse, the question is now when is it going down? And so by definition, going down is a velocity that's defined as less than 0. And so going back to look at the graph, when does this graph picture have values that are less than 0? In other words, beneath the time axis. Not just C to E. There's another section of this graph that is also below. All right, so also from 0 to A, and again from C to E. As long as you go back to the definition of what the question means, and you don't distract yourself by the sections of the graph that you think are going up and going down, go back to what the definition means. And so then we also have a follow-up question to this would be, when is it at rest? What is the velocity definition of being at rest? V of t is actually equal to 0. And so where is that happening at this picture? A, C, and E. And so t is specifically equal to A, C, and E. And that's when it would be at rest. All right, so another set of questions. Set of questions number 2. When does this have positive acceleration? And again, we talk about the weird English language. To have positive acceleration does not mean it is accelerating. You're going to have to separate those two words in your mind because it's a common misconception. This is not me asking when is it accelerating. That will be a different question. This just means when it has positive acceleration. So you got to go back to what the definition of acceleration is. Okay, acceleration is defined how it relates to velocity. Okay, acceleration is the derivative of velocity, which is the slope of velocity. And so if I want this to be positive, I want A of t, which is equal to the slope of velocity. I want that to be greater than 0. So A of t is the slope of velocity, and I want that to be positive. So where, if anywhere, is this graph having positive slope? From 0 to where? 0 to B. And again from D to E. That's where it has positive slope. Positive slope being the pieces where this has positive slope right here. These are all considered positive slope. That does not mean it's accelerating. It just means it has positive acceleration. And so we're going from 0 to B and from D to E. Whoa. So conversely, when would it have negative acceleration? So the definition of negative acceleration means that A of t, which is the slope of V of t, is going to be less than 0. And so on this graph, the section where the slope is 0 is going down there from B to D. All right, any questions so far about the way those questions are asked? Sometimes you just have to not even look at the graph. You just first have to remind yourself of what the definition is, and then tell yourself what to look for, and then go look for it. But don't look at the graph until you're sure what you're actually going to need to be looking for. Any questions on that? All right, so let's actually answer the question, when is it accelerating? And when is it decelerating? Because it's usually not what you think. So the question of when is it accelerating is actually referring to both the velocity and the acceleration at the same time. In order for this we talked about this last week about speeding up. That's what accelerating means. In our vernacular of English, it means we are speeding up. And so in order to speed up, you have to consider both the velocity and the acceleration. And what do they have to be related to? How do they have to be related to each other? In order for something to be speeding up, which means it's accelerating, How do velocity and acceleration have to be related to each other? Okay, I'm going to go with what Cassidy said. When either they are both positive, which is usually easy to find, or when they are both negative, which is the harder one to find. Okay, there are two situations of where we consider it to be accelerating, because velocity and acceleration are both vectors. And if they are both positive, that's called accelerating. If they are both negative, that is also called accelerating. And that's sometimes hard. People think, oh, they're both negative, it must be decelerating. No. Okay, the best way I can describe having to think of two negative things making you be positive is when you jump out of an airplane without a parachute. Okay, when you jump out of an airplane, you have negative velocity because your direction is down. You also have negative acceleration because gravity is pulling you down. So you are going down and being pulled down. That's two negative things. But you are feeling that you are accelerating because you are getting faster and faster and faster as the ground gets closer to you. You are speeding up even though your velocity is negative and your acceleration is negative. Those two negative things make positive feeling of accelerating. All right, so we want, what we're looking for, look for V of t and A of t to have the same sign. I don't even have to look at the graph. I can look at my yellow answers that I've been doing right here. For when would V of t, we know when V of t is positive, V of t is positive between A and C. So within that, where V of t is positive, where is A of t also positive? So all between A and C, now look at acceleration. When would that have values within it that are also positive? A to B. Now I need to look for when they are both negative. Okay. When is the value of the velocity negative? And then also, we know that the value of the acceleration is negative between B and D. So within the interval of B and D, where I have negative acceleration, where within that interval would I also have between C and D, right? Now on a graph, that's going to show up as any time the graph is going away from the time axis. And so that happens twice in two situations. This graph goes away from the time axis here. It also is going away from the time axis in that interval right there. Okay, anytime that it's going away from the axis of time, that means the feeling is that you're accelerating, which means the converse is true. Of when you're decelerating is when you're heading toward the axis of time. And so the decelerating angles, I don't know if you can see the blue, decelerating would be the intervals where you are now approaching back towards the time, because that's where acceleration and velocity have different values to each other. They have the opposite sign. And so that's going to be the feeling of decelerating, which is slowing down. All right, and so that was from 0 to A, from B to C, and from D to E. All right, the last thing I want to talk about is the graph of speed. I've colored all over my picture right now, so I'm going to get this in before the bell rings. I'm just going to recopy it. How do you convert this to a graph of speed if this is currently a graph of velocity? To convert it to a graph of speed, you need to reflect the negative sections into positive, because speed is the absolute value. And so the graph of speed would be like this. Oh, that's not a very good reflection. It also would be this little section right there. So the graph of speed takes the negative pieces and flips them above the x-axis. And usually the question will be asked, when is the maximum speed? Not when is the maximum velocity, but what is the maximum speed? And in this case, it was at D, because D ended up having the maximum speed value. All right. See you tomorrow. Thanks for a good day.